Problem 2-10. The slope of segment AB is 5, with points A at -3, -1, and B at 2n. Find the value of n and the distance between points A and B. For this problem, we're going to have to end up using our slope formula. Remember, slope is going to be the change in the y over the change in the x, or if you want to look at it like it's a formula, y2 minus y1 over x2 minus x1. And remember, you just need 2 points. In this case, we have 2 points, one of them with an unknown value. But if I wanted to say n minus -1 and then 2 minus -3, we would end up with a slope of 5. So let's substitute the things in that we know and see if we can solve this equation. So if we know the slope is 5, let's go ahead and put 5 in for m, because we know the slope is 5. So 5 equals, we'll call this 0.2, so we have n minus -1 over 2 minus -3. If you want to rewrite that, when you're subtracting a negative, it's the same thing as adding a positive. So it's like n plus 1 over 2 minus -3 is like 2 plus 3, which is 5. So we're just going to solve for n here. In order to do that, we have to get rid of the 5 in the denominator first. We're going to multiply each side by 5. And we're going to multiply this side by 5 as well. So we end up with 5 times 5 is 25. And that equals this 5 and this 5 are going to cancel out, so just n plus 1. And now let's just subtract 1. So n equals 24. That means that the value of n for this point B is going to be 224. So if A is -3, -1, B is going to be 224 if the slope is 5. So now we need to figure out the distance between these 2 points. Now we could take it and we could plot it on a graph there, and let's see what that would look like. I'm going to just draw a rough sketch. So we'd be back 1, 2, 3, be down 1, so we'd be down about here, would be like point A. And we know we're going to be going way up. So if B is 224, that would be like way up here. Actually, I don't need to label that. We'll just say that's our label for it. So we would be trying to figure out the distance of this segment that runs all the way up to there. A couple ways it could be done. We can look at using the Pythagorean Theorem. We could take it and we could kind of sketch in our right triangle here, because we're just trying to figure out this distance here. So we could say this is our unknown distance. We could call that x. But if we do that, if we look here, our coordinate here, we're at -3 and we're going over to 2. This point is at 2. So this distance from here to here is going to be 5. And if you look, we're at -1 and we're going all the way up to 24, which means this distance from here to here is 25. So one option we have there is we could use the Pythagorean Theorem. We could say that 5 squared plus 25 squared should equal our x squared, or c squared, because it is the hypotenuse. And that would be like saying 25 plus 625 equals x squared. So 650 equals x squared. Now we take the square root of each side here. And when we do that, normally it's the absolute value of x. However, we're not going to be able to use the negative version of this, but square root of 650, well, we know 25 goes into it 26 times. So this would be like saying 5 radical 26, or the square root of 650. And then in this case here, x would equal positive or negative 5 radical 26. However, we can't use the negative, so the final answer would actually end up being just 5 radical 26. Remember, distances must be positive, so can't use the negative. That's one method. The other method you could use would be the distance formula. And remember, the distance formula looks like this. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And all this really is the Pythagorean theorem just written out as a formula. So we can look at it and do it this way too. Let's see what happens. Let's plug our points in. So we'll say this is going to be 0.2. So we're going to do 2 minus negative 3, which is like 2 plus 3. And we're going to do 24 minus negative 1, which is like 24 plus 1. So we're going to have 5 squared plus 25 squared. And what you're going to see here is we're going to end up with square root of 650 again. So same thing we ended up with over here. And if you're trying to break that apart, because you didn't understand why I did it over here, this is like saying 25 times 26, which gives us the square root of 25 times the square root of 26. Square root of 25 is 5. So we have 5 radical 26 in the end. So that is what our distance here is going to be, 5 radical 26. Hopefully that helped out. If you have questions, make sure you ask your teacher. Otherwise, thanks for watching. Good luck.